Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello, everybody, and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. Today, we are visiting with Tom Whitton, the Vice President of Business Development for E2 Metrics. So welcome to the show, Tom.
It's great to be here. Thanks.
And Tom has got a lot of information to share. One of the things the first thing that we're going to be talking about today, we're actually going to be doing two episodes with Tom because it's two very, very big subjects that we have to cover that I know the audience is going to love. The first being decentralized wastewater treatment and nutrient removal. And we hear a lot about this, package plants, decentralized versus centralized. And I want Tom to explain to the audience, and this is something I want to hear, is that I am sure, and just awareness, is that decentralized facilities probably have a big variable or many different issues or pain points that vary from your large centralized wastewater treatment plants. And so if you could kind of give me a rundown 101, what are some of the biggest challenges and pain points that decentralized facilities deal with in comparison or contrast to centralized facilities?
I think the challenge around decentralized facilities is really economies of scale. The challenge around that is you very centralized facilities can have very large biological reactors, very large processing plants, so you can really take the cost per 1,000 gallons or cost per meter cube of treated water. You can bring that down quite substantially. So the economics are always more challenging when you're in a decentralized environment. Despite being smaller, you're going to have a similar labor force. Your overheads tend to be very similar, but you're spreading that over a much smaller volume of water to be treated. So then that makes the economics somewhat challenging. However, where you do save is the fact that you're not, pumping long distances, you're not spending energy, you're not sending greenhouse gases to the atmosphere by consuming energy to move water, sludge laden water long distances. So there you have to weigh all of those options as well. Plus, any sort of compliance issues around contaminants. Well, they're a little tougher to do on the smaller scale, which is kind of where we fit into the picture.
Why is that? Why is it harder to maintain compliance on the smaller scale? Is it the intensity of the makeup of the effluent?
Yeah, well, I think it's just because you very often the smaller decentralized plants don't have all of the complexities, I guess, that sort of a larger centralized plant would have. They may not have all of the unit operations, for example. So it becomes difficult, especially I mean, when you have decentralized plants, often you're also in areas which are environmentally sensitive too. And so by so if you need to meet some sort of nutrient discharge regulation to the environment, then you may be in a situation where you have a lot of difficulties in complying or what have you. So Biological processes in general do a very good job of removing
Hmm.
nutrients, whether we're talking about nitrogens or phosphorus, but they do really well when they're big. When they're small, they're not and they're much more difficult to control. So and that's sort of where we come in as more of a polishing step with our electrotechnology applications.
So explain to me, what is that electro tech? Because we talk about, you've got mechanical, you've got biological, you've got chemical, but this is something of a completely different. This is another beast altogether. And one of the things that I thought was so interesting, it said no chemical, no moving parts. I was like, okay, so how does that work?
Well, I mean, for people who are in the industry, they'll often, what we do is referred to as electrochemical. But we know the word chemical sometimes has a negative
Right.
connotation, and so we from so our marketing purposes, we'll talk about electrotechnologies. But the reality is what we do is we're taking advantage of the chemistry that could be created by inducing a current through water, and then taking advantage of that chemistry, and of course our know-how, our experience, our intellectual property, to be able to remove key nutrients, and other contaminants too. Sometimes when we're not in the municipal area but more the industrial area, heavy metals, different long chain hydrocarbons. These are all also different types of contaminants that we can remove. And so basically what we're doing, I mean, there's three different modes, and I'll make reference to these reactors that are above my left shoulder here. These are our what we call our EcoThor electrotechnology reactors. These can be configured three ways. They can be configured in electro disinfection mode, so we're just trying to disinfect the water. They can be configured in electrocoagulation mode, um, and I'll explain what that is in a moment. And then they can be configured in electro oxidation mode. So there's three different modes that these reactors can be configured. Super modular as well. They could just it's more of a plug and play type of situation, with a centralized controller, and they can then be, generally you need to adapt it for each application. But so you have these three modes. When we're referring to nutrient removal, we're generally, and in the municipal sphere, we're talking generally about electrocoagulation. So we've actually developed some expertise around um, performing electrocoagulation using magnesium anodes. Electrocoagulation and coagulation are similar and related, but they're different as well. Coagulation, typically what we do is we'll inject a chemical into the water to help drop out contaminants, and they then get, they'll get accumulated and through a clarifier or through different filtering processes, and then they get removed, in part downstream. Um, Electrocoagulation, is different in the sense that you're just injecting the ion that is needed to do the reaction. And so you're consuming a lot less elements. In this case, it's a metal. Um, we've developed expertise around taking that magnesium, looking at the ammonium that's in the water, and you also have phosphates that are in the water. So all three of those together, when you're passing an electrical current through the water, you can actually form something called struvite. Struvite is
Mhm.
magnesium ammonium phosphate,
Right.
and so that actually, frankly, has fertilizer capabilities. And you can actually take that, extract that from the water, and then reuse that for fertilizer purposes right now. So we have a lot of intellectual property around that. Um, so when we're looking at nutrient removal, if we're strictly speaking looking at nutrients, this would be, one way we would pursue that using electrocoagulation. I will add that electrooxidation can also be used for removing ammonium. because certainly these streams will have ammonium in it as well. And so this is another approach which could augment the electrocoagulation mode for removing ammonium and phosphates. It's really we'll tailor the solution for the given application. I will say that all three modes disinfect the water at the same time. So you're getting a twofer, right? You're
Mhm.
removing the contaminants and you're inerting or immobilizing any of the pathogens that are in the water. So that's certainly something that's an advantage as well. And frankly, any of the solutions that we've ever brought to the marketplace are 200 plus reactors on 25 sites. There's always been multiple benefits. We're removing multiple contaminants, and that's where you tend to have the best value, I guess, for whatever we've offered.
So I guess my question is, why this over other things that have been used in the past? Is that what is the uniqueness about this that can really be beneficial? Because we all know there's not one size fits all or one magic bullet that can solve everybody's problems, because every plant and every collection system is like a fingerprint. Every single one is unique. And so my question to you is, what's the sweet spot for this? Where can using this type of technology for treatment be most beneficial? Where's it best suited?
I think there's two situations where I think this is very well suited, and I'll be talking mainly about the electrocoagulation for the markets that we're discussing here, municipal wastewater markets. There's two areas where I think what we do can offer a benefit. One would be in small decentralized plants. There's also a lack of often manpower. And
Yep.
so these are systems where, I mean, they have these reactors above my left shoulder. They're connected to a control panel, and frankly, you can operate these off of your phone. So there's an automation around that, which is very, very advantageous. And so when you have small decentralized plants, have probably a lot less manpower to make sure that you're properly dosing the chemical to get out the nutrients. You know, often the other thing with wastewater is that it's sometimes the flows are very cyclical, meaning when we're in the spring runoff, there's a lot of water, and then it's the summer and the fall, there's less water. Biological reactors hate that. They hate that variation, and so this is these reactors can adapt very well to that situation. I would say the other application which would be pertinent would be in environments, and this could be either decentralized or centralized plants, but certainly decentralized. That tends to be where the value proposition is more interesting. Where these are environmentally protected areas where you need an ultra low phosphorus discharge to the environment. The
Okay.
Great Lakes, for example, anywhere around the Great Lakes, whether it's on the US side of the border or my side of the border in Canada. Often we're referring to anywhere between zero point zero 0.03 to zero point zero 0.05 milligrams per liter of phosphorus. Super low, very, very low. And so um, this an electrocoagulation mode can actually augment existing processes to go from, say, the zero point 0.5 or zero point 0.2 milligrams per liter down to the zero point zero 0.03 or lower milligrams per liter of phosphate. This is an area which our this process can deal with. So we're not necessarily the flocks that we're forming is not necessarily struvite in this case. We're just making hydroxide-based flocks, which can be removed. Um, Economically, the best approach is to take these reactors and to just polish an already low phosphate level wastewater, and then polish it down to the extreme levels that need to be achieved around the Great Lakes. I'm using that as an example, but there are many other pristine water tables around the continent that need protecting.
Okay. All right. Touch a little bit on, because we do have some listeners that are in the industrial space. How does this apply or can be used effectively for industrial, tertiary treatment?
I mean, everything we do in the industrial applications tend to actually be the easier solution for us. I think there's more of a willingness to consider electrotechnologies for non-public applications, and it gives what's helpful is that a lot of the industrial clients tend to have the expertise. They have let's say they have an engineer, or they have some degree of expertise in place to be able to sort of support that back and forth and that troubleshooting to be able to identify a solution. Very often municipalities are dependent on having an engineering firm supporting them, and so often that expertise is not available for industrial applications. I mean, it's this is and between you and me, this is one of the challenges that we faced as a company, is that I mentioned we've delivered over 200 reactors on 25 sites, but almost the vast majority of systems that we've delivered are one-offs, meaning we've tailored a solution adapted to the needs of the customer, and which is great. I mean, we it served their purposes, but I mean, can I take that application and say, okay, well, let me repeat this 10, 20, 100 times? And that's always been, some of the challenges. So an industrial customer, it will almost always be something unique to them. But it's totally worthwhile. I mean, certainly we've actually established a bit of a strategic we have a strategic partner for the U.S. markets. Can't talk about it yet at the time that we're taping this interview. It's not public yet. Maybe it will be public by the time. Maybe it becomes public. Then you could put it in the comments or the chat or whatever afterwards before it gets published. But the strategic partner in the U.S. who has strong ties to the municipal markets also has a division that focuses on industrial clients, and so we're working very closely with them on being able to support that.
Okay. All right. Well, I thank you for sharing all this information. It's certainly a technology that we should be paying attention to, and just exploring the possibilities and the applications for it for those ideal markets that we discussed today. And so for those of you who are tuning in that want to get more information, Tom, could you please give us the website address where they can learn more about the technology?
Yeah, sure. So we're at e2metrics.com. So that's E, the number 2, metrix.com. And I'm reachable also at T Whitton at e2metrics.com. That's TWHITTON.
Great. And you can also find Tom on LinkedIn and connect with him. And, thank you again. And I look forward to our next episode where we're going to continue our dialogue and speak on the subject of PFAS, which I know is, it's high on everybody's mind right now. And so until next time, thank you for listening and keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.